This is a short demonstration on how additives are tested using the DFR 05. We will be comparing additive A with additive B to find out which one is more suitable in improving the dewatering of the pulp suspension, which is about 0.5% headbox sample, still free from retention or drainage additives. The DFR is set up in drainage mode. This means that the stirring chamber is in a certain configuration. It has a filtrate outlet with a wide opening to let the filtrate drain freely. There is a screen. For this fast-draining sample, a 50 mesh screen has been selected. The stirring chamber is then assembled and attached to the device. Finally, the filtrate beaker is placed on the balance platform. The next step is to set up the measurement in the software. A click on New Measurement will open a setup screen. There we enter a sample name. Select the screen that is in use, it is the 50 mesh, and set the duration of the measurement. 20 seconds will be enough for this fast-draining pulp. Then a stirrer profile can be programmed. In our measurement, a stirring will take place over 10 seconds at 700 RPM for homogenization of the sample, followed by another 10 seconds at 1000 RPM to simulate shear forces. The speed during filtration is set to 200 RPM. And finally, the injection of the additive needs to be programmed. This additive is named A. We will be dosing 5 milliliters of it. And the dosing shall take place at 5 seconds, right in the middle of the 10 seconds homogenization phase. Now the pipette needs to be loaded with the additive. At first, the volume needs to be adjusted to 5 milliliters. And the additive A drawn into the pipette. Then the pipette is put back into the dosing module. You will now click in the software on Start Measurement, which will initialize the DFR for the measurement, and then the sample can be added. Another click in the software will start the measurement. The DFR will work through the programmed stirrer profile. Mix the sample at 700 RPM, inject the additive after 5 seconds, and increase the stirrer speed to 1000 RPM to simulate shear forces. After the stirring, the chamber opens and the sample is drained over the inserted screen into the filtrate beaker on the balance. The complete drainage is recorded by the software. It records a wait over time curve until 20 seconds, the duration that is programmed in the software. And after this 20 seconds, the result is displayed. This sample has released 750 grams of filtrate. With the DFR cleaned from sample contaminations, it is ready to test the other additive, B. The setup for the measurement will be the same. We just enter a new sample name and rename the additive. Five milliliters of additive B is taken into the pipette, and the pipette installed in the dosing module. The stirrer treatment of the sample is the same as for the first additive, mixing at 700 RPM, injection at 5 seconds, and shearing at 1000 RPM. By comparing the new curve with the previous one, it is already obvious during the measurement that additive A performs better than the additive B. After 20 seconds drainage time, the additive B could release only 661 grams filtrate versus 750 grams achieved with additive A. In this way, you can screen a complete portfolio of additive types, dosage amounts, or additive combinations to work out which one or two work best at a given sample, and which are the preferred candidates for the following trial program.